Welcome to today's webinar, everyone. I'm Erin. I am your resident webinar host here at Softry, and with me is Matthew Dickey, our training manager. So today we are going to be going through what I consider probably one of the most essential webinars if you are newer to RoadEng or if you're just learning about the software for the first time. We're going to be talking about some of the key concepts around corridor modeling and sort of the foundation that RoadEng is built upon. So these key elements are essentially like building blocks that really set the software's foundation for being able to do corridor modeling. So today we're going to explain each of the 5 key concepts and then do a little bit of a demonstration of what they are and how to work with them. So the first of these concepts is the terrain model requirements. So namely, you need to create a TIN. And this TIN is needed in order to be able to build your RoadEng project. Next, we're going to be talking about the centerline and cross-section model, talking a little bit about how these elements interact with each other and that aforementioned TIN. Third, we're going to talk about report points, and these are very important. Probably one of the most important concepts that we're going to talk about in the webinar in total. They really play a very important role in the software's volume and cross-section calculations. From there, we're going to talk about a couple of volume-related topics, including the average end area model, the basics of the mass haul, as well as expansion and compaction factors. Finally, we're going to wrap up and discuss a little bit about material movement and the concept of the Opti-Haul, which is a reporting method. But to set more of a foundation, really before we move into these concepts, especially for those of you who are newer to RoadEng or in your infancy of learning the program, we're going to just jump into a very quick 3-minute mini demonstration. RoadEng key workflow steps. We're going to start by importing our topo or our survey data. In the example that we've got up here, we're importing a couple different LiDAR tiles. With those tiles, the next major step is to take the points and turn them into an actual sort of 3-dimensional surface. Using our generate TIN dialog, we can create that TIN model, and you can see it here. And then the final step in our terrain module is really saving that file. So we save that in our own proprietary format called a TERX file, and then we're able to reference this original ground surface over in our location module. So in the location module, the first step here really is to start a new project, not an open project, but a new project that references that terrain file that we just created to show our original ground. From there, we would usually set our cross-section or adjust it, but given this is a 2 minutes and 30-minute video, we're just going to go with the default, but we could set up our cross-section or adjust it. And then it's about creating our horizontal alignment. So being able to click it in or leveraging some of the optimization tools that are available, and certainly not in the context of today's webinar, but we could automate that creation a little bit more. So we're able to add horizontal curves as well. They've got the curve panel. So again, you kind of get the general workflow behaviors. We're clicking in points, we're applying curves, and we're going to do the exact same thing in a few steps over here on the vertical as well. But as you can see, lots of windows, it's all interactive, it's super dynamic, and yeah, it's all updating in real time. So from there, we can keep iterating, adjusting, and then we move over into our vertical. So similar to what we just did in the plan window, in the profile window, you can click to create an IP, click again to adjust it, and then we'll go on to the process of adding curves as well. So it's the whole workflow really is all about this sort of dynamic interactivity between the windows and getting your alignments in the position that you'd like them to be, and then adding the details. So I think, I don't know, Matt, I kind of skimmed through that at the surface level.
I'm amazed for just getting thrown in to talk about something that you weren't planning on. Yeah, good job. You covered the bases. Yeah, of course, we can spend more time than just 3 minutes running through this, but that is the gist of it.
Yeah, and a couple things, especially for the context of what we're going to be talking about today, to pay attention to. We've got our plan window. You can see that the plan window is at a specific station, or I should say the section window is at a specific station, the same where the plan window point would be. So they're all updating interactively in these different views. You've got the profile, the section, the plan, the 3D view, and then we've also got the additional sort of material reporting shown here in the mass haul. And we're going to sort of touch on all these elements and how they interact. So the final steps in a core workflow, obviously getting it for output or construction, adding culverts, a bunch more steps we could have done, but just from like a super simple high level overview, that's sort of a little bit of the essentials of RoadEng. So as we start talking about these actual different foundational concepts that are today's official webinar topic, that first sort of step in that video was really that creation of the tin surface of the terrain model. And I should say there is one notable exception to that necessary need of the creation, and that's if you're working with a P-line traverse. But that is another story for another webinar, specifically a forestry specific webinar. So obviously we cannot design a road in the air. We need to understand what the original ground looks like. This original ground surface could come from a variety of different survey data formats, such as total station, which I've got a little picture of up here on the screen, LiDAR data, DEM, GPS, pretty much any standard format that includes elevation with the points. So the type and the accuracy of this survey data can vary, and we'll touch on that briefly on my next slide. But the survey data points themselves are just data that's been imported. So once we bring it in, we've got points, but we actually don't have an official surface. So that kind of brings me to that next step that we just went through in that workflow, which is that creation of the tin. And a tin stands for a triangular irregular network. Basically, it's connecting the points with different triangles, and then these triangles form a surface. So it's possible to, enable it so you can actually see the triangles, which we've done here. Most people do not design with their triangles showing, but you are able to review them and look at them if you'd like. And that's sort of what forms the surface. So using our terrain calculation dialog. Here's a better look at sort of the typical view you would get after you've got a tin created. I did mention briefly that there's sort of differences in accuracy and quality. So I think it's really important to mention that not all tin surfaces are the same quality, not all tin surfaces are the same resolution. So the vertical and horizontal density, as the accuracy of the points and how they were collected, really does define the quality of the tin surface. And RoadEng will pretty much work with any tin surface you give it. So it really comes down to being an engineering decision whether or not you are comfortable with the quality of the survey data that you've put in for your engineering projects. And you can see with the pictures here, basically going from some really, really coarse SRTM sort of level data here on the left through to a much higher resolution LiDAR data set on the right. Okay, with that, enough of our PowerPoint for a minute. I'm going to pass the screen over to Matt. He's going to jump into RoadEng. We're going to talk a little bit more about the terrain modeling needs. And that sort of core concept.
All right, so I don't have to worry about following a video here. So if I'm out of sync, it's a connection issue, and I'll apologize for that. So as Aaron introduced, first step for designing a road is we need a surface to design from. So I'm going to just pop open terrain here, and I'm going to bring in a total station data set, and then I'm going to bring in a similar LiDAR data set. So in here, I'm going to just bring that in. So it's a CSV. We can see we've got a series of points and lines in this case. If we look at the 3D view, we can see, well, there's clearly elevation data associated with that. But to turn it into a surface, we tin it. And there we are. Now, the way this gets modeled is, well, as Aaron introduced, we've got a series of triangles that make up that surface. But something that's universal in terrain modeling is that the points and lines that we're working with have properties associated with them. So I'm not going to spend a ton of time talking about that here, but for example, let's look at this point here. So this point right now is being displayed, so we can see it in the plan in 3D view. It's got elevation data associated with it, and it's modeled. Now, if I turn this modeled property off and I regenerate that surface, I can see, well, it's actually floating in space right now rather than being attached to the model. So these properties are going to be, well, influence how that surface gets built. Another common property that's really important to get your surface to behave the way we'd like is break lines. So with this, if I take, say, this line, and it's modeled as a break line, if I turn that off and I regenerate my tin surface, I can see now the triangle edges are allowed to cross that feature. So we can use those triangles to, well, force things to behave the way we like. And with this, we've got, well, even with all the points to make up our contours, we've got 9,000 points. If we compare this to a LiDAR data set, we can largely ignore a lot of those properties and still get a good surface. And with that, it comes down to the fact that rather than relying on break lines to get a surface to do what we like and having points measured at certain important spots, we're just going to beat it with a lot of points. So here we've got about 2.6 million points. We come in here, we model it. There's no break lines, it's just a bunch of modeled points. And away we go. So 2 different flavors, whether the data comes from LiDAR or total station. In terrain, it really all behaves the same way. It just comes down to the properties associated with the features. With that, I'll send it back to Erin.
Okay, our next concept is all about the cross-section model and its interactions with the center line and the tin. So let's just kind of explain this one through a few images. So here we have that tin surface that we literally just stepped through. So we've created a tin surface. So now we can add a center line on top of it. And I should say, we are visualizing this using the terrain model. Most of the time you would be creating this inside location. So please ignore the icon and the screenshots. We just needed terrain in order to step you through the different pieces. So we have our center line drawn down here in the bottom. We kind of have this crossing line over top of our center line. And that is where this particular example of our cross section is being pulled from. So this is a cross section. It's sort of like a perpendicular slice to the center line. And RoadEng uses a cross section model that is attached to a center line and is defined by a station range. So you could have a few different types of cross sections that are being applied by station range along your alignment. Now, each of these cross sections, or different cross sections, I should say, is sort of like a mini program, and it's going to dynamically adjust based on the cross section position and, the center line position and the tin surface around it. One other thing to note before I sort of flip to the next slide here are these purple spherical symbols. These are our report points, and we're going to talk more about those in a couple concepts from now. But they are denoting the location where the cross section is being calculated, and that's really feeding the design of this road. So the cross sections themselves, I mentioned, are kind of like mini programs. They are adapting and changing based on your topography and based on the materials that it's sitting upon. So in this screenshot here, you can see that we've got these sort of hatched lines here are 2 different subsurface horizons. And if you look really, really closely at the cut slope, you can actually see that the cross section, through its mini program definition, is adjusting the cut slope angles based on the material that it's in. It's also adjusting for the presence or inclusion of a ditch. You'll see it's here on the cut side, and there's no ditch on the fill side. Similarly, you could do the same for berms. You could do the same for a variety of different elements within the cross section. So they are dynamic mini programs that are going to adjust to the center line's location, the ground types, as well as just the overall topography. Now, today's webinar is obviously not about cross-section templates, but I did want to highlight a couple of really great resources if you are, looking to learn more about them. The first of which, obviously, the top 10 concepts you need to learn. Great for beginners in RoadEng, and if you're on support, we have an awesome advanced webinar that we're happy to get you to the link to as well. So be sure to include those in the follow-up email, as well as in this video description for those of you interested. So with that, cross sections and the way that this model is calculated are an essential part of RoadEng. I'm going to pass it back to Matt. We're going to go in the software and learn a little bit more about this topic.
As Aaron introduced, we've got our cross section showing in my cross section view here. I've got a 3D model down here that's, well, taking our center line. We have our cross section attached to that. And if we look at this, we can see, well, we've got this cross-section geometry here, and we've got this cross-section geometry here. So we can assign these different templates, cross-section templates, by range. So I have, well, on my left side, I've got my default for the majority of my road, and then I've got a section where I have my rock fill template assigned. Right, we've got something very similar here. Now, if we were to go back here and we were going to pull this alignment out, we totally can, and we can see, well, as Aaron introduced, the geometry is updating in real time, and well, going from having a ditch to not having a ditch, and everything is adaptive in that kind of template mini program logic. Now, these templates that we are pulling from are stored in our template editor. And with this, there's a few advantages of the template editor just by itself, rather than having these attached to the alignment and not being able to see how they work. We can pull these around without adjusting our vertical alignment here and seeing how they're going to behave. Now, the templates are, well, we have the template itself, where we have a few parameters, but the bulk of the parameters in here come from the components. So I've got a roadway component. I can come in here, and if I want to have a different width, I could just assign that, and we can see how it updates in real time. And yeah, that logic, we pull it down, see if there's a ditch versus no ditch. Cut slope here versus going way down into that rock material, we've got a steeper cut slope angle. So those parameters are all just set basically like a fillable form. We've also got point codes. We can pull in other templates to deviate from the original by going into the e-library. And we can see we've got a bunch of folders here. So if I wanted to say add in a Jersey barrier, we could take the Jersey barrier from this and add it into our components. But for the sake of time, and we will be tight on time on this one, I won't go into much more detail here. Yeah, we've got some prior resources that are useful for it. One thing that I will mention, just because it's going to feed into our volume calcs here, is the idea of surfaces. So here I've got my subgrade surface that's being hatched. I've got my surface volume 1 being hatched, and then out here where I've got my stacked rock fill, I'm tracking that as surface 4. So few key concepts related to templates. We'll unpack those in more detail in some of our other resources and future webinars.
Okay. If you have pivoted away from the webinar, this is the moment when you should, pop back, check it out. This is the most important concept, I'd say, of the entire presentation, and probably one of the most misunderstood concepts in the software, and that is report points. So I mentioned these briefly before. These are these little purple symbols here on our center line. I should say they're not just the purple symbol. They're actually the lines that are going across them. And report points are basically cross-section calculation points. They really do help us to make sure we get reasonable volumes and a reasonable representation of site geometry. Now, obviously, due to computational time and space, we cannot include infinite numbers of report points. So it's really up to your project and your, what type of road you're doing in order to decide how frequently you would like your cross-section calculations to be occurring. What's the frequency of your report points? Now, they do come in a bunch of different categories and types. There is one called an auto interval one, and that's the sort of standard one that's going to be used throughout your project. And then additional report points get added when you implement curves, when you add culverts, there's also another one that comes in when you sort of explore a particular cross-section. That's your standard editable report point. You can also add those in manually. So there's a whole bunch of different classes of report points, but there's sort of two major concepts that are sort of worthy of going deeper on. So the first is a very easy to understand one. The more report points you have, the more accurate the volume calculations from your design. And we'll just take a quick look at an example of a switchback that has too few of report points. So you can see here in this one curve, there is definitely not enough report points happening. The curve has not been properly visually defined because there is a lack of report points. So if you add more report points into it, you now can start to see the proper curve geometry is being visualized and the volumes that are going to be calculated from that are much, much more accurate. Now, the second concept is really that tied kind of into this point of diminishing returns. If you have too many report points, you're obviously going to slow down calculations and make the designing process slower. And here's a really great visual to help explain that. So on the left, we have far too many report points. These report points are not adding any additional volume information really to this project. Whereas on the left, at a much lower, actually more regular frequency, these report points are capturing pretty much the exact same volume, but they're keeping the software really light. So this is that second key concept that yes, you can add too many because you're going to start to have a significant impact on your computer's performance, especially for our clients who are working in those extremely long road projects, the ones that are up in the 20, 30, 40 kilometer range. Yes, report points do play a very, very significant role. With that, let's go into the software. Pass it to Matt and have a little bit of a deeper chat about this most essential concept that we're talking about today.
Alrighty, so I'll just share my screen here, and just to start, we'll look at that same file. So this one, I can see in my 3D view, everything appears like a road, but we'll come in here and we'll see where those report points are actually landing by just showing our sections in the 3D. I find the 3D really useful for visualizing this. So each one of these cross sections of 3D is a report point. So we have in our options a bunch of different classes of report points. Now here I've got a auto interval. So at most, the space between these report points is going to be 5 meters apart. But in cases like, well, say from here to there, so that's at 75. If we go 675, 673.2, well, that's probably this transition. So in order to get a nice transition to show where I've got that taper being applied, we've got an extra report point being added in there. And we've also got extra report points at things like beginning and curve, end of curves, profile points, etc. So this is a list of all the different classes of report points. Now, if we go to something like this, this is that same design, only we've got some really kind of ugly looking line work outside of our center line. Our surface, same thing, it doesn't really look all smooth and nice. And well, it may be that we're missing some important information to get reasonable volumes. So here, and again, I'll just turn that on so we can see what we're dealing with. My report points are set quite sparse. I'm going to reduce this. So going from 50 to 5, and there we've got something much smoother, much nicer to look at. Our volumes would have changed a bit here, but really for this, it's more just to make sure that the surfaces that we're modeling are appropriate. And it looks nice, so no one wants their road edge to go through their center line and pop out the other side. So yeah, that's report points. We have access to them here. Auto intervals are customizable. Some of these are system defined. Standard report points are another really useful tool, or if you want to have a report point right at a certain location, we can right click, add edit report points, and just click and add that in or move it to wherever we'd like. So there we are. And then lastly, related to report points, throughout the software, aside from just creating that model, we use those report points to control how we're reporting things. So in this case, my data table is being set to report points every 100 meters, and then at the start and the end points. And then similarly, if we're doing a multi-plot and we want to report our cross sections or control our pagination settings, yeah, it all comes from in there. With that, I'll send it back to Erin and we'll continue along.
Okay, I knew we were going to be tight for time, as always. So our next concept, or I should say group of concepts, is all about volumes. So to start, let's discuss how volumes are calculated within RoadEng's location module. So it's using an average end area volume calculation, which essentially means that it's calculating the cross-sectional areas and then applying those to a specific length. And the report points that we just talked about are dictating how often these cross sections are being calculated, so the length between them. I want to just also make sort of a caveat. So this is inside of location. It is possible to do volume calculations inside of the terrain module as well. And that's done through a very different means. That's, I believe, a subtractive tin volume calculation. So inside of location, we're using the average end area. Yeah. Anyways, that is a brief discussion of how we're calculating. Next sort of volume topic, or part of the volume topic, is really how we're reporting some of these volumes. So most of you know the mass haul is a reporting method for volumes along the length of our road. The bottom axis in the mass haul here, this is chainage, and the purple line is the material balance. So as we start here on the left side of the cross section where we are predominantly in cut, you can see it here, the mass haul rises. We're creating material surplus from those cuts. Moving sort of past the middle here, we have sections of more fill, and the mass haul falls as we create a material deficit. And then finally, on the end, we sort of start to get a little bit more balanced with our cross section, and the mass haul flattens. So the mass haul is a really useful tool, standard amongst pretty much every geometric design software, to help you understand your material balance. And we're going to talk about some limitations of the mass haul actually in our final concept today. But for now, that's the mass haul. The last sort of layer in our volume calculations really all applies to materials and the fact that they have different states. So materials have three main states. The first is banked or in situ. Then we have loose, so this is once the material's been taken out, and before it gets to its final placed state. And each material, whether that be rock, whether that be clay, whether that be gravel, you name it, has different behaviors in these different states. And it's really important for the software to be able to account for these changes in volumes by material as we transition between these states. So the volume of natural in-place material typically, there's obviously caveats to this, but typically expands after it's excavated, or it could contract, and we can be able to account for those adjustments through expansion and compaction factors in the software. So this is a really, important concept. It has a huge impact on your volumes and it's sort of real world application, and you can account for that within the software. So we're going to pass it to Matt. He's going to talk a little bit about the sort of key volume concepts, mass haul, the expansion and compaction, and then just generally how it is the volumes are being calculated. And I'm sorry if we're flying through the speed of this webinar, guys. We are, notorious for not booking enough time to talk about concepts, but hopefully you are kind of getting the ideas and the main sort of themes from the presentation and the software demonstrations.
Cool. Well, I'll dive into volumes, and all these subtopics that we're touching on today, we can and do have whole webinars dedicated to them. So we are really just trying to hit the high points with this. But lots of resources available for kind of a slower, more in-depth take on these individual items. So volumes, and here I'm going to deviate from having kind of that real example that we were looking at to something that is super, super simple. And that is, well, how does this look if we've got just a flat terrain and a really simple cross section? Well, I've got my cross section on my topo surface, and I can just go in here and we'll click measure, and we can go across here and we'll see that, oh, and I clicked in a bad spot, but we'll be close enough that we're at, I won't click in a bad spot because I want my numbers to at least a cross-sectional area of 9.7. So our cut cross-section 9.7 square meters. Our fill, in this case it's the same, 9.7 square meters. So if we deal with that over a 10-meter segment dedicated to it, well, we'd be dealing with 97 cubes. Now, this example that I have here, we've got, well, from 0 to 4960. I've got my volumes here, and we're right in that realm of what we should be. So that's the gist of it. It's based off the cross sections that we're sampling at those report points applied to the distance. Now the next thing to unpack here is our mass haul diagram. And here my mass haul isn't very interesting at all, because it's just showing that mass haul, well, being empty, and that's because the mass haul's on the 0 line. Now I'm just going to switch over to show a different design. So same surface, just a little bit different geometry. And here, well, our mass haul is not on the 0 line to start. We have a section, well, right here where mass haul is climbing. So we can see we're cutting a whole lot more than we're filling. And really the mass haul isn't as smart as the Opti-Haul, which we'll talk about later. But the mass haul, all it's doing is tracking our surplus and deficits along the length of the road. So if we're creating more cut than fill, well, we're creating a surplus of material, and that mass haul rises right until, well, we hit a point where we are balanced cut and fill. So 0 surplus, and at that 0 surplus mark, the mass haul is going to be flat. So if you're in true cut and fill, if you are along a surplus to start and switch back to cutting and filling, well, your mass haul is just going to be level or flat. Now, as we go to a point where we're filling more than we're cutting, that mass haul line is dropping down. And then if we have something like this, where we're back to 0 and just flopping it from one side to the other, well, we're following along there. Now this mass haul diagram, as we track that surplus, a lot of the time it's used to approximate material movement. So here we've got different categories. We've got our free haul, which in this case is our movement less than 100 meters, and then we've got our overhaul, so our movement from 100 meters to up to 500 meters, and then anything beyond that would be end haul and assumed to be tracked. Now, with this, as we get into tracking that surplus and deficits, well, shrinkage and expansion becomes, well, important. If we want to know where our surplus and deficits are, well, we want to make sure usually that we have the right amount of cut to balance out our fills. So our fill factors live in our ground type table. So right now I have my sub-horizon assigned to be OB. I've got my fill to be set to be whatever layer 1 is. And with a fill factor and a cut factor of 1, everything's balanced. Now, of course, some materials get bigger after they're excavated. So if you are dealing with solid rock and you expect that to, well, puff up afterwards, if we change this to be 0.8, so we're going to assume it expands, we can see our mass haul is now showing us a surplus. So what that 0.8 means is, well, if we leave our cut value at 1, we're relating the fill factor back to that. So we're working in bank cubic meters, and we're saying that, well, if we dug a 1 meter deep hole, set our material off to the side and tried to fill that back into the hole, we could only fit 0.8 of it in there. So it's expanding. Now, conversely, if we were dealing with something that's not rock, like loose clay, and we expected that to shrink, and we put in a fill factor of 1.2 here, well, we can do that, and we'll see the opposite happens, where that shows a deficit. So as far as your mass haul and tracking materials, that cut and fill factor is important. The actual concept of where the volumes are coming from is pretty straightforward. We've got that cross section. We look at the end areas and we apply them to the length between the report points. And then I guess the other thing is just the fact that the mass haul itself, it's not a black box or overly sophisticated. It's just looking at, well, at station 200, for example, how much material have we generated by that point as a surplus versus a deficit? So 2,500, and then back by, say, 750, we're 2,600. We've gone up to a surplus of 7,400 at the peak. So that's volumes, mass haul, and I'll hand it back to Erin, and then we'll look at a little bit more complete approach.
Perfect. Okay, last concept. Sorry, we're over time, everybody. So let's just talk about, ever so briefly, some of the deficiencies in that mass haul. So the mass haul, just to start, it's an industry standard. It's in RoadEng. It's obviously not exclusive to us. So the mass haul is very much a single material focused method of reporting volumes. The fill in this graphic, it's treated as a single material, and it doesn't really solve the question of where does the material come from and go to, and it doesn't solve fill composition at specific stations. The movement heavily based on proximity. So we have our own proprietary sort of method for solving these problems. We called it the Opti-Haul. Really original name, optimal haul. We love that word, optimal. The Opti-Haul is a method of reporting volumes where we're kind of solving those big challenges. And it's as simple in your project as just toggling it on to use Opti-Haul volumes. So the Opti-Haul is multi-material, so it's handling and tracking each material separately and balancing them. And it really solves the very complicated question and problem of what goes where, what gets included in this part of your road, where does it come from, and how are those expansion and compaction factors applied to that specific material, and how is that fill comprised. So it's really, really detailed, and it acknowledges and accounts for the fact that there are predominantly composition fills that can happen in these projects, and it's really solving for that. So Terrible quick intro from me. I'm going to pass it back to Matt for our last concept. We're going to talk a little bit about the Opti-Haul. And again, like all of the concepts that we have mentioned here today, we do have a lot of resources available on each of them individually. Here, we're just hoping to skim the surface and arm you with some information or just an awareness of the concept and that it exists and what's driving it. And hopefully, yeah, if you're interested, dig a bit deeper and leverage those other resources. So, Matt.
All right.
Coming back, final time. And then we'll hang around to a couple minutes to answer some of these questions that are coming in as well.
Perfect. So I've got that same design that we've been looking at throughout our webinar today. And this one, before just diving right into talking about particulars, we're going to talk a little bit about the way this design is set up. So with this, I've got a few different materials being used. Some of them, I've got a 1-to-1 fill factor for that. My hard band's going to expand. Solid rock also going to expand. I've got some unconsolidated material that I expect to shrink. Yeah, some silt that I expect to shrink as well. So those are assigned in my subsurface horizons here. And I can see, well, if I choose any part of my alignment, we'll go up here. I'm cutting both my fractured rock here and my hard pan. Now, with that, if we go back a little ways, so if we choose this draw here, well, the way I have this assigned for my fill types, and the way the software, the MassHaul, the conventional MassHaul is looking at it, is I've got my fill type just set as a common fill. So that common fill, the MassHaul isn't, or yeah, the conventional MassHaul, it isn't solving for that common fill, probably isn't going to be exactly made up of what we've told it it's going to be, where it's going to just say, well, that common fill has a fill factor of 1.05. So let's show our MassHaul. And we can see right now my MassHaul is actually showing that this is not balanced. But if we switch this to show MassHaul with Opti-Haul, they're balanced. And why is that difference there? Well, when we use the Opti-Haul volumes, it's actually accounting for the fact that I've said that this fill type is replaceable. So as long as the cut material that we're working with is Q2 or better, which would be Q1 would be our worst material, so I can't use any old garbage, we can use it there. So this fill in our prism probably isn't just one material, it's going to be a mixture of the materials adjacent to it. Similarly, if we go down here, well, the fill in this section is probably going to be a composition, but it's probably not the same composition as up here where it's taking the material that's close by. It's probably taking the material that's close by to this, which is, well, some unconsolidated material instead. So right there, the Opti-Haul is going to give you a much better approximation of your volumes, that surplus deficit. So you can feed it into getting a proper material movement. The other side of the limitation of the MassHaul, so right now I've got my MassHaul with Opti-Haul volumes. The MassHaul here isn't really doing it justice, so if we have something that can't be used or has to be used somewhere else. So I'm going to switch this just over to show two graphics. We won't split hairs here, but I can see, well, I've got some material going ahead, I've got some material going back. That material is going back to a spoil site. Well, why is that? And the way we have this set up, we've got some silt out at the end. I want my subgrade material to at least be made out of material that is Q2 or better. That silt material that I'm looking at is Q1, so when I set it up, I'm saying it's not usable, and that's getting hauled back to be disposed of. The other side of things is could be, well, we could say that this prism here, well, let's say that that surface 4 needs to be created out of solid rock and not be replaceable. We'll hit OK. We'll hit OK. And now we can see that we're hauling in our rock to those, well, rock fills as needed too. So it's, again, not a black box by any means. It's just a tool to account for the realities of building something. If you're building a stacked rock fill, you need to have a rock source to build that. Yeah, so it's taking something that would be really tedious to figure out by hand and almost impossible to do without, or to design as balanced without spending an enormous amount of time and just putting it all at your fingertips and making it easy to get better results. And with that, I'll hand it back to Erin and probably question time.
Perfect. Yes, we are going to tackle a couple questions, but I also just wanted to share that sometime today, we're going to be launching our new version 11 training course. So in particular, that last example where Matt was talking about material quality and fill composition and all of that sort of very material specific details, that actually is part of our training course. And you can step through quite a detailed example in the course that introduces you to those concepts. It does also go front to back, as well as all the other exciting new tools in version 11. But this course coming out today, there will be an e-blast that announces it as well. But if you are wanting to learn a little bit more and go more in depth, just wanted to draw your attention up to our new training course, and we'll be sure to include that as well in the follow-up. Okay, with that being said, let's tackle, a couple of the questions. And perhaps, Matt, I'll just pass it back to you just in case you want to have a screen sharing here.
Okay.
Our first question is, could you please clarify whether the road's vertical alignment is created from the top layer of the road centerline or the bottom layer?
Okay, well, that is a dealer's choice. So with that, it's just up to you, however you have it set. If I go into my templates, so this one, I've got my default template applied to this location. I have my template, and we can zoom in here, and we see the template is attached to my center line, so that's subgrade. Now, it doesn't have to be. If we'd rather that at finished grade, we've got B align at top. It's just a matter of changing that template here, and we can do the same on the other side, and away you go. So entirely up to the user, however they have that set. If you wanted to get weird and apply some additional offset, you totally could do that too. The templates themselves are really flexible, easy to use, and then if you want to dive into your own template customization, you can go down that route as well.
Okay, the next one's a great and I think actually decently common support question, which is about controlling cross-sections display in multi-plot. So it says I use the report points to control my cross-sections, but sometimes some of them are missing.
All right, so let's assume this is for our cross-section view. So just switching over to multi-plot, and I don't have one in my design right now, so I'm just going to bring in a pre-formatted cross-section cross-section chapter. And so right now I've got my alignment, and here, well, I can see I'm getting one every 5 meters, which might be desirable. But if we want to change how frequently we're seeing those templates, we can go into our layout, see the cross sections, point type, and here I've got it set to show every 5 meters. Maybe I want to change it to show every 25. Great, we can do that. And I don't think I might have a few pipes in here too. So if I want to show another category, we can turn that on and we'll hit OK. So now I've got a lot fewer of my sections. And well, here I've got a pipe that doesn't land on those 25-meter intervals. It's landing where I have my culvert. So the gist of it is select your subview, click layout, point types, and then you've got access to all of your report points to show what you'd like. And if those standard editable report points, if you want to have cross sections at a specific point, you totally can. It's just a matter of referring to those ones that you've added in with the standard editable report point class. You can also use the pagination settings to have this so it behaves differently in different portions of your road. With that.
Awesome. Let's do one more. I know we're so over time, but let's do one more. And this question is back in the cross-section template space, which it is, can we have a conditional template in the location module?
Totally. And well, however far down the rabbit hole you want to go, I believe the answer is going to be yes. It's just, yeah, what way do we show it? Conditional, one example is just the fact that the ditch is there versus not there. We've got a bunch of these components that some are quite simple, others are quite smart. And you can build these out with your own logic to match whatever you'd like, but let's go in here. So here's an example where I've got a mine road template. I've got a probe depth for whether there's a berm added or not. So that berm is getting added if I've got a drop height greater than 3 meters. We can get even fancier with, if you're a mining example again, bench cuts that are going to add the benches as needed at levels to keep those benches flat, even if your road is on a different grade. Similar, we've got alls that can add in your different level of blocks, and they can also keep the footing flat or level as well if your road's on a different grade. Yeah, so all sorts of different conditions being accounted for and logic being baked into these. And then if you want to build something entirely from scratch, you can click that little customize button and dive into the deep end of things. But yeah, all sorts of flexibility.
Okay, and with that, I know there's a whole bunch of questions left here. We're so over time, so we are going to wrap up. For the few question askers that are remaining, we will follow up with you directly on your questions. And as a reminder, for those of you here in the live version of the webinar, you will receive your certificate by email. It usually comes about an hour after completion, as well as a follow-up email once this video is up on our YouTube page. So thank you everyone for being here today. Hopefully I know we went fast, but hopefully you were able to take away some of those core concepts, especially report points. And we look forward to seeing you guys at another upcoming webinar soon. Thanks, everybody.
Thanks, everyone.